Hello again, students. Welcome to this now our third lecture in algebra, and in today's section we want to factorize or focus on factorization. But before we do that, you recall in our last session you were given this exercise here to complete, which is exercise 4.2. The answers are provided here, and you can quickly look at it and mark the exercise. Okay, should be done with the marking of that exercise. If you have any questions regarding that, you can raise that in the discussion. Moving on to the next section, which is factorization. Factorization can be viewed as the opposite of products. And remember, in the previous section we started off with brackets and ended up with expressions, and in this case you start off with expressions and your answer would have brackets in them. Although a bracket is considered an expression, but therein lies the difference between products and factorization. So here you notice here in this example here, you start off with an open expression and end up with brackets, and the reverse is the products. Let's have a look at how we have arrived at this particular answer and what our thinking was. You recall earlier in the year you may have done something called factorizing using prime numbers under the arithmetic section, and also HCF. So that knowledge is important for this section for factorizing. If you look at A, that example has 3x plus 18, and we're going to end up with an answer and with some brackets in the answer. And if you look at these two terms, this is a variable term in the variable x. Here there is no variable x, so there are no variables that are common, so it's just numbers. And if you look at the numbers, and if we factorize the numbers in terms of 3 there, so it's just going to be 3 times 1, so that's going to be 3. And 18 is going to be 2 times 3, which is 6 times 3, which is 18. So what is common to these both? The only thing that's common to these two terms is the number 3. So I'll write down the 3 once, and what is left here is going to be 3 times something is giving me 3x, so it's going to be the x. Plus, I've taken out the 1, 3, so what is left here is just going to be 2 times 3, which is 6. So 3x multiply that 18. If you are to check using products, you can use products to check your answer. So going in that direction there is factorization, and going in that direction there is finding products. So therefore they are considered to be the opposites of each other. So you can always use products to check if your answer is correct during factorizing. B. B. So here we have an expression with 3 terms, and we want to factorize it. So in the first one we have just x. In the second term, 2 cannot be broken down further, neither can x, neither can y. And in the last one is the same, none of them can be broken down any further, so you have 3x, y, and z. Let's try to put that down there. Okay, so the only term that is common to all 3 is the term x. So if I write down the term x, what am I left with here? Something times something must give me x, so it has to be 1. Because sitting in front of the x is the 1. Remember, we spoke about that previously. That is actually 1 times x, or 1x. Plus, I've taken out the x, which is written down here. I'm left with 2y. Plus, I've taken out the x. I'm left with 3yz. Check your answer using the reverse process. You should get that question using products. So you can't get these things wrong, because you can always check your answer and know when the answer is wrong. 16, this is C now. BC. Okay, let me write on the bottom here now. 16 can be written as 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. And that's going to be ABC. 8 is going to be written as 2 times 2, which is 4 times 2 is 8, and that's going to be A times B times B. And 24 is going to be written as 2 times 2, which is 4, times 2, which is 8, times 3, which is 24, times B times C. Okay, this is a rather long way, but obviously I'm just doing this to show you how we use our previous knowledge that we did earlier in the year, and why we did that, because it is required here. So the numbers that are common to all of them here is that, which is 2 times 2 times 2, which is 8, as being common. Also common is the A. Sorry, I don't see any A here, which means there's nothing common there, so that's out of the question. If we look at B, B is common there, the B is common there, and the B is common there, so B is common. And the C, yes, it's there, it's there but not there, so it can't be common. So this is the only term that's common to these 3 terms. And what am I left with here? 8 times what is going to give me that 16, and it's going to be this 2, and it's going to be the C that's left. The next one is that. It's going to be a minus sign as well. 8 times what is going to be there? That is out. That's out. So the only thing I'm left with here is this A here and then B. And the last thing here, that is common. I'm left with 3C. Test your answer using products, and you should get that there. So 8 2s are 16. A is missing here. So this is a very good example, although it wasn't intentional, but it just happened to prove the point that I was just making. You can test your answer using products. So actually I left out the A there, so you can write that as A there, and that's C. So that means there it is not common. We originally thought it was common, it is not common. Right? So there we go. I'm now by accidentally found an error using the reverse product rule to see. Okay, I must start the A there because A is not common. 8, that's going to be 8ab squared, correct? And that's going to be 24 BC, which is correct. Okay, let's move on to the next one, which is D. Which is 3y squared plus 12y. Now I'm not going to go into doing this laborious factorization. It was just to give you an idea of why we did things previously, and you already can work out in this case here it is 3 that's going to be common. So the number that's going to be common there is 3, and the variable that's going to be common is going to be y. So that will be what I will be left with is y, and that which will be left in the second term is 4, because the y will be out, and 3 times 4, 3 will be out, you'll be left with 4. If we look at the last one there, which is E, which is 3x squared plus 9x cubed plus 12x to the power 4, and the number that's going to be common is going to be controlled by that. It's going to be 3, and the variable that's going to be common is going to be x squared, because x cubed is x squared times x, and x to the power 4 is x squared times x squared. So that's going to be x squared, and I'll be left with 1, because if you take out all of this, 3 times 1 will give you that, plus 3x plus 4x squared, and if you multiply that using products, you should get your question. I just want to add one more type of question, and we can call that F. As an example, F, which I've added here, which is 3a into a plus 3 minus 4 into a plus 3. Now what we've been dealing with previously here, we can put that in the category of common factor. This one here will be in the category of compound common factor. Compound common factor. What we've been doing so far, common factor, where the factors that were taken out were just terms. Now this bracket here because it's a bracket and involves at least a binomial, we say it's a compound common factor. So actually this is what is common. So what is common, we extract it outside the bracket, and that would be equal to a plus 3. I've extracted that and I'm left with now 3a minus 4. And always check that with what is left, there's nothing else that's common here to these two terms. And a quick check, there is nothing common, but it would not be the case that every time there is nothing common, so you'll have to check this bracket as well. So you are now in the position to do exercise 4.3, which is on page 78 and ends on page 79. You need to complete that entire exercise, which we will look at in terms of the answers in our next session. Our next session is going to be on equations and solutions of equations. Bye bye until then.